What is it that is at risk? Is that human life? Is that an emission of hazardous chemicals to the environment is at risk? Overall community safety is at risk?
Welcome, everyone, to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Samir Koranne. He is the Global OT Lead for IBM's X-Force Incident Response. And our topic today is a topic that, Samir is very familiar with, cybersecurity for petrochemical manufacturing facilities.
Okay, here's you and Samir.
Hello, Samir. Thank you for joining us. Before we get started, can you tell us a little bit about yourself and about your role at IBM?
I have about 20 years of experience overall in IT and cybersecurity industry now. Initial several years I have spent in Microsoft application development, providing the applications with .NET, SharePoint. We supported the products that had geographical information systems, BI tools, and that was probably 2/3 of my career so far. And about six years ago, I had an opportunity to get into space of cybersecurity and got hired in a chemical manufacturing company. So that was my first formal start of cybersecurity career. I spent a few years providing support on intellectual property protection, and for last about more than 3.5 years, I was supporting operational technology cybersecurity. I recently joined IBM as operational technology lead for X-Force Incident Response. My role at IBM is defining and executing a global strategy on OT incident response, and that involves providing the practices, processes, and support that is required to bring up our capabilities, maintain our capabilities on operational technology incident response.
So our topic is cybersecurity in petrochemical manufacturing. We have never had anybody on the show from petrochemical manufacturing. Can you start by telling us, what is this? What's the physical process? What processes are involved? How does it work?
Starting from the basics, petrochemical manufacturing can be referred as basically petroleum refining plus basically the byproducts that we have from refining to use on several different chemical manufacturing plants, basically that are producing resins, plastics, rubbers, solvents, industrial chemicals, or coatings or dyes. The product range is quite wide. We can call these manufacturing processes or manufacturing plants into two different segments. Maybe there are more, but I'm not a chemist by my profession, so I can only speak based on what I have learned so far and how I have seen it from my lens. There is a commodity manufacturing. So this is a large scale manufacturing of the products, which is of course based on the scale and size that is required in the market, the demand of the product in the market. These are going to be huge, large manufacturing facilities. And then there are specialty products, and those could be discrete processes where the production could be in the batches. If we think about this, the manufacturing of the chemicals, it's quite essential for overall economy as well. Not just chemicals, but basically the petrochemical industry itself, because all of the range of products we find or they are produced, we can find them in several essential materials that we use on daily basis. if we think about just responding to the pandemic that we have, the rubber, the solvents, the chemicals that are used, the shields that we use, the PPEs that we use, all of have some form of plastics, materials, coatings. These are all petrochemical manufacturing industries that are producing either the raw material or the final products that are going into these. So um, these are all very essential industry or manufacturing plants for our overall day-to-day life and products that we use in our life.
So that all makes sense. These are products we use every day. Um, when we're manufacturing them, though, what kind of equipment is involved? What kind of chemicals are involved? And what are the risks here? If there's, let's say, a worst case cyber incident, if the very worst that's possible happens, what are we worried about? What are we trying to protect against here?
So the chemicals that are involved in manufacturing could range from really hazardous chemicals to the chemicals that we could probably find um, not so hazardous. Let me put it this way. But um, taking the example from Department of Homeland Security, the CFATS provides us the list of harmful chemicals, and that is basically for the risk reduction program that CFATS has observed. There are several chemicals that you can often find on these chemical manufacturing plants. If there is a leak of those chemicals, either uh, the chemical that is in a liquid form or chemicals that are in the gaseous form, there could be a severe impact to the people who are supporting these operationally at the plant site. And some of these chemicals could certainly have an impact in the community, not just limited to the plant and plant operations, but to the community which is around those manufacturing plants. So the consequences could definitely be severe based on what chemicals are being utilized. Of course, not all plants are exactly the same. Not all plants are using the same amount of chemicals that are hazardous. And that's where the distinction has to be made. What's the quantity that we are talking about? What is it? What is it that is at risk? Is that human life at risk? Is that an emission of hazardous chemicals to the environment is at risk? Overall community safety is at risk. There are different dimensions we could study based on what chemicals are involved in this. And consequences are finally what we are trying to avoid, as we have always said. Industrial control systems, cybersecurity, first and foremost priority is to the life. There, we cannot put any value to the life. So certainly that becomes the most prominent risk or consequence that we want to avoid.
So we're coming up on the industrial security question in a minute, but sort of one last step of introduction. In these facilities, what does the automation look like? How are computers automating these facilities?
Normally, depending on the size of the production that we are talking about, typically we will also find the combination of control systems, and this could be distributed control systems, which are used definitely for the complicated processes, very involved processes that we could find in these huge manufacturing facilities. We already talked about safety instrumented system, ESDs. Those are very typical as we are dealing with harmful chemicals. We want to ensure the production is secured, safe. So safety instrumented systems are part of that. We also will find ad hoc PLCs doing some or supporting some discrete processes. Uh, this is mainly from the large manufacturing facilities. If we are going to the specialty chemical production, we could certainly find some prepackaged instruments. These are also called as uh, these are different. These are designed for supporting the specialized chemical processes to design or develop specialty products. So these could be prepackaged PLCs, bunch of PLCs working together to support different intermediary processes to create the final or end product. So combinations could be endless, depending on the size of the plant that these systems are supporting. There could be hundreds or even several hundreds of equipments that are involved in this, supporting the automation of the chemical process.
Andrew, I'm familiar with SIS as Safety Instrumented Systems, but Samir used a term there that I don't know. What is an ESD?
I had to ask too. I hadn't heard the term before, but he explained to me, and I looked it up afterwards. The ESD is an emergency shutdown system. So, technically what I've been thinking of an SIS, I've been thinking of sort of the whole thing. I've been describing an SIS as something that monitors for unsafe conditions, and when it detects one, shuts everything down. Well, it turns out the SIS is actually, it's like a PLC. It's a little computer. It has one job, monitor the inputs and, figure out if the shutdown signal needs to be sent. And if it needs to be sent, it sends the signal. What shuts the process down? It's not the SIS. All of the logic involved in saying, close these valves and open that valve and open this emergency release and on, that's the emergency shutdown system. So the SIS triggers the emergency shutdown system.
I see. And one other term that I was a bit behind on, what are prepackaged units?
Yeah, so again, I asked him about that offline, and he explained. He said, look, in the petrochemical manufacturing industry, there's sort of two fields. There's the commodity, the volume field, where you have raw inputs and you're producing outputs. And these sort of really big iron factories, these refineries, these whatever you call them, tend to be configurable. You tend to be able to take a variety of inputs, combine them in a variety of ways, and produce a variety of high volume outputs. He said in the specialty chemicals, often you are combining stuff that's sort of so specialized. There's very little variation that's possible. I think one example is like automobile windshields. You've got glass, you've got multiple layers of glass, you've got plastic inserted between them. You got to insert the plastic in a certain way so that there's no bubbles in it, because you can see that through the glass. And, you can produce automobile glass. You can produce sort of the tougher stuff that you put into, locomotives in train engines. You can produce bulletproof glass with, even more plastic layers between layers of glass. But that's kind of all you can produce, because the equipment you have is sort of specialized to working with these materials. You can't use something that produces windshields to also produce, carrying cases for laptops, even though the raw materials, the petrochemicals, might be the same. And, he was saying for these very specialized units, often, in a refinery, you might say, I'm going to go with Siemens and have 90% of your PLCs be Siemens or Honeywell or, Allen Bradley or somebody else. With these specialized units, you'll often need a specialized unit from one PLC vendor, another one from a different PLC vendor, and these vendors have to work together and program these PLCs and produce the higher level stuff that can manage these very specialized processes. So, when he talks about prepackaged units, you'll often buy these things as a package with lots of stuff from lots of different vendors in it to do this one very specialized thing. So you've worked with a wide variety of different kinds of petrochemical manufacturing facilities. Can we talk about industrial security? What do these facilities do? Sort of, what's the state of the practice there?
Air gapping or the segmentation is still a big thing, as this is also a recommended best practice. Following the industry best practices 62443, creating the segmented networks, segmenting individual production plants, even segmenting the safety instrumented systems, segmenting those with industrial DMZ to IT network, still are the basic fundamentals that are being followed. There are a lot of developments, however, going through, as a lot of governments as well are trying to come up with the regulations or the requirements that will be imposed or we should not call it imposed, but would make companies responsible for how they are protecting such critical infrastructure. As we we can always debate whether these companies are in critical infrastructure or not. However, we just saw an example. The products that are manufactured are used in our daily lives. If they are not available, we can certainly start feeling the impact of it, and we have had that experience last year. So in my view, chemical manufacturing companies are also critical to the economy, to the sustainability of the products that we need in our daily lives. So that becomes critical from my point of view as well. Government regulations, CFATs, maritime security, those are in the US quite prominent. Maritime security related recommendations are pretty brand new, an year old probably, but still is a step in the right direction. European Union has already produced their guidance. Germany is working on the IT security 2.0. GMI and BSI in Germany are quite actively working on these. China has taken the cybersecurity law, and they are, of course, improving those requirements as we speak as well. So there is quite a lot of activity around the world on critical infrastructure and critical infrastructure protection. There is a lot of higher awareness and visibility thanks to all of these supporting companies, governments, and also the industrial control systems, cybersecurity organizations. They have put the OT security to heightened awareness. Companies are taking real interest in ensuring what protection measures are implemented, how they are ensured, just by not doing the segmentation, also by putting it to the test, by performing active risk assessments, working with the vendors to install the detection mechanisms that are valuable for learning what's going on in their OT networks. So the field of OT security, industrial control system security, is extremely active.
Now, I'm curious, you mentioned maritime security, but we're talking chemical manufacturing. Are you seeing, I don't know, chemical manufacturing sites out on the ocean, or why is maritime security involved?
There are several companies, the chemical companies, on the coast of the on the coastal areas, situated on the coastal areas. They have access to the barge docks. They have access to the waterways, feeding them their raw material or shipment of their final products. Now, as soon as you get into that zone, certainly you are getting either the specific sites, specific areas are coming under the Coast Guard regulations, and that's where maritime security related requirements has to be followed by those specific companies or sites or facilities.
Just a word of clarification there. My understanding of what Samir is talking about here is the sort of the volume commodity chemical manufacturing facilities. They prefer to be close to a shipping lane or, on the coast. If you're producing massive amounts of gasoline or plastic feedstocks, you need a way to get those products to the consumer. And, for gasoline, it might be the end user. But for things like plastic feedstocks, you need to get them to another part of the world, another factory that's going to use those feedstocks to produce something else. And shipping is the cheapest way of doing that. And when we have chemicals coming together with shipping, this is where the port authorities get involved with their safety regulations. This is where the maritime regulations get involved. This is the connection there is what I saw. Earlier on in your explanation of the state of the practice, sort of another clarifying question here, you mentioned air gaps. What exactly do you mean by air gaps? Different people seem to mean different things.
I agree, Andrew. This term is thrown around and used in several different ways, and we have to ensure that this term is utilized or used appropriately. It needs to be, from my perspective, as I see it, air gapped is no connectivity to any other network. So when it comes to the risk assessment, you want to understand, and typically the safety systems were air gapped as what we were always considering those. There is a need for this. They are designed for emergency shutdowns, and if you want that system to be that reliable, at that high reliability, also from the security perspective, more secured, they always called for having air gapped safety systems or emergency shutdown systems. It all makes sense when we look at it from that perspective, that safety is of paramount importance. We have to do this. However, we have to understand that, and I have seen this, I have experienced this through my colleagues, my friends who are working in the industry. Several companies are even not there. They have a lot of flat networks, even connected OT systems. So all of this, when we are promoting this or we are providing the updates to the higher management, we have to be crystal clear on what we mean. Air gapping from internet is not really air gapping. We have segmented that network. We have stopped the traffic, yes, but that's not air gapping. When we want to protect those automation systems, we will have to rely on the segmentation. If your safety systems are not air gapped, that's not the end of the world, of course. Segmentation does work. There are systems that are integrated, that are interfaced, and those are segmented by firewalls. Nothing wrong in that. However, you have to ensure there are appropriate protective as well as detective controls established to ensure your cybersecurity at a heightened level. You have to use those terms correctly so that your management understands what you are trying to get the money for, justify your investment in cybersecurity for OT. So this will help to ensure your program makes sense, program gets budget that you need, management understands how you are protecting the automation systems.
Waterfall Security Solutions is the OT security company. If you're wondering what is the difference between a unidirectional gateway and a firewall, or a so-called unidirectional firewall, then you'll be interested in Waterfall's latest ebook. Firewalls are used throughout both industrial networks and enterprise networks. But best practice demands something stronger, something truly unidirectional at the IT-OT interface. To see the difference that unidirectional security makes, please download the free ebook, Firewalls versus Unidirectional Gateways, from the Waterfall website under the Resources menu.
To be honest, Andrew, when you ask Samir to define what he means by air gap, to me, it kind of seems redundant. I mean, I agree with his definition. Air gap means no connections anywhere at all, right?
That is the way I always understood, what the term meant. But like I said, I've recently run into sort of a population, a perspective on industrial security that uses the term differently, that uses it to mean lack of routable connectivity as opposed to lack of all connectivity. The important thing is that, that when people talk to each other, if they're going to use almost any term, they have to get a mutual understanding of what it means. I mean, the worst case is something like this. I might use the term air gap to mean lack of routable connectivity. And I'm talking to my boss or my boss's boss trying to spring free some budget, some funding for improved network security. And if I use the term air gap to mean lack of routable connectivity and my boss or the boss's boss interprets the term to mean lack of all connectivity, he might look at me funny and say, why do you need more money? You're already air gapped. We're done. It's over. Go do something else. And you don't get the money that you need to make it more secure because you're talking past each other as to what the word means.
So how did we end up with two, what I would consider non-compatible definitions for one term in the first place?
That's a long story. One of the big problems with operations, with engineering, with industrial security is that there's so many different specialties, people coming in and trying to cooperate to get stuff done. And the thing is that in the industrial space, in the engineering space, there's a huge history. I mean, we had industrial operations before we had computers. And the first computers that were used that we tried to apply to automating industrial automation, they were woefully underpowered. Generally, each computer could only do one little tiny thing. So you needed lots of different computers that doing, a huge variety of things. You invented a name for each kind of thing that each of these computers did. And now in the modern world, we have much more powerful computers. Basically, one computer, one software can do everything. And we invented a whole new terminology for that class of computer. And, now we actually had standards bodies coming up saying, whoa, this terminology is all over the place. And they tried to invent standard terminology to try and pull together some of these other concepts, which just added even more terms into the mix. So, how we got here, it's a long history. Any field that's as old as this, I'm guessing, has these kinds of terminology problems.
So I think that we've made the point that it's not just semantics. This is a real problem. The question now is, how do you deal with it? What is the solution?
Here's the solution I use. It's worked for me. I offer it up as something that would work for anybody else. When I go into a prospective customer site, when I go into an industrial site, I am not shy. When people use a term that I think might be just a little ambiguous, I ask them what it means. If they use a term I've never heard before, I ask them what it means. In sort of corporate culture, people might think, oh, that's a sign of weakness. If I want to persuade these people, I can't be admitting that I don't know what's going on. In my experience, exactly the opposite is true. The terminology is so arcane that every site, almost every site, even within the same company, every site, every group of engineers uses a slightly different or sometimes a vastly different terminology. And asking what things mean and starting to echo the terminology of the team back to them tells them, you care about getting stuff right. It makes you part of the team. It's not a sign of weakness. It's a sign that you want to become an insider. And once you're inside and you're using their terminology, now there's no ambiguity. When you make a recommendation, they understand it. You're talking their language, and cooperation becomes that much better. So learn the terminology, ask questions, use their terminology. If you come in from the outside and say, I'm from enterprise security, you will do it my way, and start using a terminology they're not familiar with, it's going to be hard sailing. So that's a lot of regulations. That's a lot of, requirements out there. Where do you start? How do you address all of these rules?
I think as we really think about this, we could really start with a topic that could be as simple as risk management. Easier said than done, though. However, that becomes the fundamental for whatever we want to do and implement. We do risk management on a different scale in business every day. Applying this similar fundamental methodology to the cyber is what helps us get our management approvals, implementing protective or detective measures, and everything that we want to do. So creating having a risk management overall in the organization cannot certainly start without having a good understanding of what we have. And that has been a classical issue we have faced always. And probably all of us are facing this in different capacity in all of our organizations anyways. What do we have? If we don't have the clarity of this, if we don't have a good understanding of what our asset base is, we really cannot do much, because that forms an integral part of all risk management, cybersecurity strategy, whatever we want to really build and scale or sell to our management to be able to make the investments in the right form. Having the assets allows you to ask the questions: what is the business criticality of this asset? If that business criticality is available, you can protect it accordingly. So having a risk management framework is nothing but having a document that tells you how you manage the risk. That's fundamental part of the policies. But when it has to be put into action, your asset base is what really is something you can build on. So I feel really passionate about the overall concept of having the risk management framework that can guide an organization how you address these topics, and then fundamentally start with your asset information repository, make it solid strong, keep that, have the processes that can help you build and maintain this quality of the data over the life of the systems going forward is important, so that you can start uh, using that information for your risk assessments and the decisions that you take that are adequate to mitigate the risks or accept the risks, however management would like to address the situations.
So that makes sense, but sort of in the abstract, you talked about asset inventory, you talked about security frameworks. Can you maybe give us a concrete example about how to apply these concepts?
Asset inventory happens to be near and dear topic to me, that because it's so foundational for security. You cannot protect what you don't know. And with the technology modernization, we see a lot of IIoT initiatives that are going on. And in some ways, I find it scary sometimes to think about all the initiatives that we have going on and how it ties up to the asset inventory. Understandably, giving you an example that I have personally seen, somebody comes up with a brilliant idea. All the ideas from the industrial IoT probably are going to have any positive impact or positive outcome for the operations, right? So that's the intention of doing all of that. So bottom line, I'm not challenging any of those initiatives. I respect those completely. That's going to improve our reliability, our operations, our process improvement, everything understandable. When I put my security cap on, I find it, I'm nervous because I'm putting a new IIoT device in the field. I'm putting probably more edge devices in the field. Some of those devices are connecting over GSM, sending the data to the cloud. Some of these are going to be connected to our Wi-Fi network, maybe in the IT. Maybe there is a Wi-Fi network available, or Ethernet Wi-Fi network, I say, wireless 6, possibly with the advancements in the plant network as well. And now you have several of these devices on your plant premises. Are you really taking into account the inventory of this? Are you managing who are the owners? How are you going to ensure how these will be maintained going forward? And maintenance, not just from their physical presence. Think about the firmware updates. How are all these devices going to be managed in the future?
To clarify, Andrew, what is the difference between? I just assumed that when you're tracking your systems, when you're tracking stuff. But what is the distinction with the IoT application specifically?
Well, the tricky bit here is the network. Most people don't sit down with a spreadsheet and say, "Here's a list of all my assets." That's error prone. What they'll do is they'll get some technology. They'll connect it up to mirror ports on all of our OT network switches. And now the technology can see every packet that's exchanged on those switches. It can build up an inventory by watching the traffic, figuring out who's who, figuring out who they're talking to, build up the inventory. And, if you're used to doing it that way, you might say, there, that's my inventory, and not realize that somebody else who means well, someone else who's doing good things with automation and who's saving the company money, somebody has deployed a bunch of industrial Internet of Things edge devices that talk straight out to the cell phone network, straight out to the data network, straight out to the internet. None of that traffic is passing on the network switches anymore. And so our inventory technology is blind to those devices that are talking straight out to cellular. This is why different vendors of intrusion detection and asset inventory technologies are constantly expanding their technology so that it sees more, so that it counts cellular devices and Wi-Fi devices and Bluetooth devices and everything that might be part of the automation, the operations. It takes technology to keep an asset inventory current and accurate. It takes understanding on the part of the engineering and the security teams. It takes determination to keep that inventory up to date so that we know what we need to protect and how exposed it is and how much trouble we're in security-wise. You're new at IBM now. You've been there, a couple of months. Can you talk about what you're doing at IBM? Can you talk about your focus there?
My role is Operations Technology Incident Response Lead in X-Force services, where we are providing the incident response services. One thing I like about how the group is structured and how the offerings are structured, X-Force provides the proactive and reactive services on incident response. And that's always been, when I was looking for the services, that's something I was highly looking for, something like this. Who can prepare me for the incidents? That means incident response planning. Can somebody also take the effort of guiding me through the tabletop exercises? Can somebody do some threat intelligence for me? Can somebody do threat analytics for me? Can somebody do strategic threat analytics for me? All of those services are clubbed under proactive services of incident response as IBM offers it. And then, of course, there is reactive services. That means, oh God, I'm hit with the incident. I need experts who can provide me active guidance on containment remediations. How do I ensure I'm secured again? What needs to be done in this case? Forensic analysis that is required. So that's part of the reactive services. So my focus from my perspective is providing the support to the industrial clients on getting the proactive and reactive services on operational technology. So be it tabletop exercise, you want to design it for your operational environment. We will try to be as close as possible to your operational environment, take those data and create a tabletop exercise that could fit in your environment, digestible for your process technology experts. And that's something is just a sliver of an example of the services, but that's my role, OT Incidents Response Lead for X-Force.
Well, this has been great, Samir. Thank you for joining us. Before we let you go, is there a thought you'd like to leave with our listeners?
One important lesson that I also learned and I would like to share with everybody is avoid the shiny object syndrome. Cybersecurity at the surface of it, of course, when we try to get into the details, can get quite complex. However, the foundational things that we can get done are going to be most important for our cybersecurity program success. So concentrate on asset inventory, maintain the good quality of asset data. That's utmost important. Segment your networks. Your OT networks need special attention. Please segment them. They do not have to mingle with the IT assets. Ensure you are applying hardening measures and access controls. So these four things can bring us a lot of mileage if we do this right. So OT security is not that difficult if we start doing the foundational things right. So that's my departing thought for everybody.
Those seem like some pretty agreeable takeaways to me.
They do. I mean, you have to get started. The basics are where you start. You know, in terms of urgency, I'm thinking about the Colonial Pipeline incident of just a couple of weeks ago as we're recording this. It'll be a little bit longer when this episode gets published. But, you know, what happened there? Targeted ransomware, the bad guys, a reasonably sophisticated attack group, got into the IT network. And the pipeline was shut down, apparently out of an abundance of caution. Presumably because the organization, the owner and operator, couldn't tell if the pipeline was at risk. And if you can't tell, you have to shut it down. So, you know, what I'm thinking is, Samir, what he's doing for IBM, for the X-Force, they're doing proactive incident response planning, planning for the inevitable incidents. Bring these people in, run a desktop scenario. Say, look, I've got a targeted ransomware group, reasonably sophisticated, loose on my IT network. How many of my chemical processing plants am I going to have to shut down right now out of an abundance of caution? If the answer is too many, then, well, that's the information we need. We have to get going with the basics of a security program that is robust enough to keep us going even in the face of the inevitable compromise of our IT networks. That's my takeaway.
Okay. Well, thanks to Samir Koranne for speaking with you, Andrew, and thank you, Andrew, for speaking with me.
Always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.